Hey, hello. My name is Daniel de Olarte Panoaya, and I am civil engineer student uh, of University Politécnica de Tlautla, o Universidad Politécnica de Tlautla. In this video, I'm gonna talk about reinforcement analysis using the stiffness method, and then uh, I'm going to talk about the example 13.5 of the book Structural Analyst by Hibeler. And in this example, um, it says determine the force on element 2 of the assembly shown in the figure if the support adjoint one sits uh, 25 millimeters down. Consider the inertia and elasticity, 8 per 10 to third kilonewtons, and it's here the figure, and as the text said, 1, 2, 3, and 4 knots, and the highest 3 meters and 4 meters. And then it's the solution. The global coordinates are established at node 3 to know the degrees of freedom, and with these dates we can create the matrix of the displacement. And in the text it said 0.0525 meters, and we need to establish an our matrix, okay, for the displacement. And then we can create the stiffness matrix of elements in global coordinates with the following expression. It is built in such a way, and we have the way that we can create our matrix for the stiffness matrix of elements, and following the expression we have for the first element, this is the matrix, and the weight in which the rows and columns are arranged are given by the numbering of the displacements as well as the numbering of the knots, okay. And for the second element, it's the same. The way in which the rows and columns are arranged are given by the number of the displacement, okay. And we know the magnitude of the longitude, okay. And the third element is the same, and the next step, we integrate the global stiffness matrix K, okay. We need to put in order because in the next step we are going to separate our matrix to know the displacement that we don't know their value, okay. Once the stiffness matrix is formed, the components in the global force Q acting in the reinforcement are related to its global displacement d. Okay, and this is the way Q equal K for d. Okay, and by making the product you obtain. Okay, and this is the structure of this or matrix and displacement matrix. Okay, and we can create our system of equation to know the what are this this displacement. Solving the system for the displacement number 1, this is the result, and displacement 2, this is the result. 0.0055 and minimum 0.0218 meters. Okay, as within any action or reaction, we put to know the force and the supports, knowing the internal force in the element through the following expression. Okay, now element for the element number 2 in this case, we can substitute the values and this expression and this matrix, and we can make the product, and we know what is this force in our element. And in this case we have 13.92 kilonewtons, and this is the same process is repeated for element 1 and element 3, obtaining the following values for each one. And these values and these magnitudes of the force which correspond to the values of the reaction and the supports correspondingly. Okay, and that's it. And in this video I would like to be interesting, and it can make the difference, and you can following this process, and I think it's easy to follow. And that's it. Take care, and we watching in another video. Okay, see you, bye.